Hi everyone, in this video we're going to go over another Leetcode question, minimum path sum. Major tech companies like Google, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given a m by n grid filled with non-negative numbers, find the path from top left to bottom right which minimizes the sum of all numbers along its path. Note, you can only move either down or right at any point in time. So we have a grid. We are looking to find the minimum cost path that goes from top left to bottom right. And in this case, the minimum cost is 131,111. So there's another path here, 11421, 13521 is another path. And I can only move either down or right at any point in time. So the output is 7 in this case. 1311 is my minimum cost path. So if you are applying for companies like Uber, Amazon, Google, the companies that focus on self-driving cars, flying cars, self-driving drones, etc., you will see this question quite often because this is kind of pathfinding algorithms, minimum path algorithms, dynamic programming is often asked during the interview, sorry. So let's try different approaches to solve this question. The first approach I want to try is greedy. If I use greedy approach, I start from this cell, and every time I will go either right or down according to this node. And every time I will pick the most optimal way, the cheapest way to go. So I can either pick 3 or pick 1, and I'll pick 1. And here I can either go 5 or 4, and I'll pick 4. And here 2 and 1. And this path will cost me 9. And this is more expensive than this, 7. So greedy is not working in this case. So what other approach can I try? Excuse me. Another approach would be using recursion. Basically, I can create a tree of all the paths that I go through, and with the using memorization, so keeping the numbers in memory, I can solve this question. But there's a better way to do it. It is dynamic programming, bottom-up approach, and using cumulative sum approach, we will solve this question. Let's get on the whiteboard and try to solve it. So let's delete this. This is not the first time I'm recording this video. Every video takes a couple of hours to record, to be honest, and I'm quite new when recording videos. So let's delete this. So basically, I have a grid, and I will start from the top left corner, right? The cumulative approach is, I will first fill the first cells, okay? Because the first cell, I can only go from this cell from left. So my value is here is 3, right? Sorry. My value here is 3, okay? I can come to this cell either from left or top. A top is missing, and I will pick the minimum of top or left. A top is missing, so I will pick left. The cumulative sum is the value I have plus the value on my left, and that will be 4 total, right? So I have another one here. I'm in this cell now. I can either come to this cell from top, which is missing, so ignore this grid, this is just a copy, or left. I have a 3 by 3 grid. So top is missing, left is 4. This is my first cell. And this will be 5. Excuse me. So then I need to fill this part, because to be able to this part, to be able to fill this cell, I can either pick from top or left, right? So I need to fill this side as well. So my current cell cost is 1. And I will come from top, and that will cost me 2. It's cumulating the total cost as I go through, right? So my current cell cost is 4. Please, again, I'm repeating, don't get confused by this matrix. This is the same as this. I'm just copying it here. This is only a 3 by 3 matrix. This is the first row, this is the first row. So my current cost is 4, and the number coming from above is 2, and my cost to come here is 6. Okay? Right, so inner cells. My current cost is 5. I can come to this cell either from left or top, and I'll pick the minimum option, the most optimal option, so that will give me 7. My cost to come here is 7. And here, my current value is 2. My cost to come here is either 6 or 7. I'll pick 6, and that will give me 8. And here, I have cost 1. And I can come here either from top or left. Top is 5, I'll pick that one, so that will give me 6. My final cell cost is 1. I'll come this cell either from top or left, I'll pick top, and that will give me a total of 7. This is another proof. So if it was 1, if I come from left, that will give me 9, and that's what we saw in the greedy approach, and that was wrong. So I'll pick 6, and that will cost me 7, and that will give me the total sum that I need. So how are we going to implement this in the code? Let's see this. First, we picked rows and columns. Grid.link, grid.0.linked is my rows and columns. We have an outer loop and inner loop. This is O(n) squared time complexity approach, okay? So we go through the matrix 2 times. And this is going to give us O(n) squared. So if my first cell is 0, 0, sorry, my first cell is not changing, okay? I can't come here from top or left. So we put it here. If it's 0, 0, then just continue. If one of them is 0, here, see these 2 if checks. I'm either coming to this, if j is not 0, I'm coming to this grid from j minus 1. So that means my current cell value plus grid of I j minus 1. Okay? And same for this one. We are doing these 2 rows and columns, right? Grid of I j plus grid of I minus 1 j. Because j is 0, I is not 0, right? I is not 0. So I minus 1 j. Excuse me. So we are now in the inner cells. We filled the first row, fill the column as well. Now it's time to fill the inner rows. How do we fill it? We check grid of I j minus 1 and grid of I minus 1 j. So this cell and this cell, I j minus 1 or I minus 1 j. We will find the minimum of one of these, right? I j minus 1 and I minus 1 j. We'll pick the minimum of it and we add I and j, and that's it. That's what we did in the grid anyway. We'll pick the minimum of one of these, I j minus 1 or I minus 1 j, and add the current I and j, and that will give me grid I and j. Okay? In dynamic programming questions, you will often see a DP array that you create in the beginning. Okay? But in this question, I'm simply overwriting the grid, so it's not the best approach, but it doesn't matter in this case. It's accepted. So we are updating the grid I j minus 1 or grid I minus 1 j, right? So either coming from left or top, we will pick the minimum of this, the most optimal one, the minimum, plus the current cell value is going to give me grid of ij. And finally, I will return the very last number I find, grid rows minus 1, grid calls minus 1. So that will give me the last number, and I will simply return that as the answer. Let's see this. Excuse me. So I and j 0 continue, I is 0, j is not 0, then do j minus 1. I is not 0, j is 0, then do I minus 1. Okay? Then either j minus 1 or I minus 1. Left and top cells that we are looking for. We are picking the minimum, right? Then return the final cell. Let's submit and see. Okay, this seems like it worked. So this is pretty much it for this question. I hope it was helpful, and I have more videos coming up. So if you subscribe to my channel, we can meet again later. Thanks for watching. Goodbye.